Hey guys, Mr. B here again, bringing you another sweet, wicked, awesome math video. So this is part 2 of my I am out and you guys need to keep going video series. Last question we looked at was a sphere. So sphere is a relatively easy shape because it only has two variables, volume and radius. And this is an example of a cone. So let's give this one a shot and see what happens. So a water tank has the shape of an inverted circular cone. So with a base radius of 2 meters and a height of 4 meters. So what that is code for something really important, and we'll talk about what that is in a second. And like as you're doing this question, like, man, I would never pick that out. Well, the thing is, every cone question is kind of like it. Some of them are kind of more overt than others, but they always have that little piece of information that relates the radius and the height, and we'll see in a second how we can use that. If water is being pumped into the tank at a rate of 2 meters cubed per minute, so that is volume rate of change, find the rate at which the water level is rising. So we want basically the rate at which it's rising, that would be d height, or change in height over change in time, so dH over dt, when the water is 3 meters deep. So that is a moment in time right there, and that is our height is 3. So first of all, this is a cone, so take you back to grade 10 math. The volume of a cone is 1/3 pi r squared h. And again, if we were doing an assessment, I would provide that to you so you wouldn't freak out and have a mental breakdown because you didn't know the volume of the cone. All right, so the issue with this formula, as I mentioned, compared to the sphere, is that we have r and h. So we need something where we can eliminate one of these variables. And that something is this little piece of information I alluded to. So the radius is 2 and the height is 4. So again, doing this question for the first time, you might not pick up on it, but as you do a bunch, you'll see there's always a piece of information with a cone that you can use. So, and basically that information is that 2 times the radius is equal to the height. So if I times the radius by 2, I get the height of 4. So 2 times the radius equals height. So now if I want an equation for the radius, all I need to do is divide both sides by 2, and then I end up with the radius is the height divided by 2. All right. So that gives me another equation which I can use over in our main equation to eliminate the r variable. And the reason why I'm choosing to eliminate r is that I want the rate of change of the water level rising. So rising means height, therefore I need to leave h in the actual equation, okay? So basically now I would take that r and then sub it in. All right, so let's sub that r. I was gone away for a few minutes, but you guys, it was only a second for you guys, so. All right. I know, nerd stuff. All right, so 1/3 pi. So where that r is right now, I'm going to sub that h over 2. So I put the h over 2, which is right there, and then I square it, and then I have my h. So I've eliminated a variable from this equation. So now I just need to sort of tidy this up a little bit. So pi, so 1/3 pi. And then I'll square both the h and the 2, so I get h squared over 4 times h. And then I'll tidy this up just a little bit more, so I can combine my h's to make an h cubed. And then the 1/3 can times with this 4 here, and that becomes 1/12. So 3 times 4 is 12. And then pi, and then h squared times h, so that's h cubed. So that's my volume, just like that. So now, second thing I need to do is take the derivative, like always, All right, so once I have my equation worked down such that I can take the derivative such that I have only one variable on both sides, then I can go ahead and do that. So the derivative of v is dv over dt. And you probably hear a screaming baby in the background again. And then the derivative of the h cubed, so the 1 over 12 pi, that's just a coefficient, so that stays where it's 2. And then the derivative of h is 3h squared times dh over dt. So really easy to forget that, so make sure that you remember to put that dh over dt in. So again, I got a couple things here now that I could sub in, but I'm going to tidy this up a little bit. Again, there's not a whole lot to tidy up. Basically, it's just a 3 can match up with the 1 over 12 to make it 3 over 12, which then turns into 1 over 4. So I can tidy this up to be 1 over 4 pi h squared times dh over dt. So all I did, just to recap, was I took this 3, multiplied it to the 1, so it became 3 over 12, and that reduces down to 1 over 4. So that's 1 over 4 pi h squared times dh over dt. So now I've got a couple things. So I've got this h equals 3. So remember, we talked about that in the last video. That is a moment in time when it is 3 meters deep. It's only 3 meters deep for an instant. It keeps going up and up and up after that, okay? So that's my h value. I also have, that I never wrote down here at the beginning, I have my change in volume. So dv over dt is 2 meters cubed per minute. So I know it's a volume change because of the units. Remember, we talked about the units, how important they are, and they can help us identify what type of change it is. So this is a meters cubed per minute. So change in volume, volume is cubed divided by time. So I'll start subbing some stuff in. So I got 2, 1 over 4 pi, and then my h cubed, so 3, or h squared, times dh over dt. So we got some options with this. We can divide right away, but anytime you got like a 4, like 1 over 4, some fraction here involved, I'm just going to do my little trick where I cross multiply one way. So it's the same as multiplying both sides by 4. So I end up doing 2 times 4, which is 8. And then that's 9 pi. And dh over dt. And then I want to get rid of that 9 pi, so I can divide both sides by that 9 pi. Just like that. And then I end up with dh over dt equals 8 divided by 9 pi. And again, we'll look for a unit. So height is in meters, and time this time is in minutes. So meters per minute. And that is our related rate. So hopefully you guys are starting to get the idea that once you wrap your head around some of these problem-solving questions, that they're really similar, all right? So I'm going to jump straight to the next one. I'm not going to break this into 2 videos. So let's have a look at the next one. And again, if there's any questions or whatever, you can relay them when I return, which hopefully won't be too long. So we have another cone question, it looks like. So this one's a little bit different than the last one. So it says sand is being dumped from a conveyor belt at a rate of 2.3 meters cubed per minute. So maybe I'll write this stuff out as I go this time. So that's my dv over dt. And I know it's volume because of the units, meters cubed per minute. And forms a pile in the shape of a cone, whose base diameter and height are always equal. So that's what I was talking about, is like some questions, the piece of information they give you in a cone is more obvious. So that's a perfect example of how this is the more obvious type. So I can write that diameter is equal to height. I don't know, you might be hearing my wife yell at my child up there, so I'm sorry. Diameter equals height. So then that becomes 2r equals height. Okay. So how fast is the height changing? So again, that's my dh over dt, which is a question mark like that. That's what I'm looking for. So again, when it comes to this 2r equals h equation, I want to solve it for r so I can eliminate r from my volume equation. So now would actually be a great time if you wanted to pause the video and try this one on your own. So you know the volume of a cone from the last one. So why don't you go ahead and pause the video and everyone try it, and then you can watch the solution and check your answer afterwards. But I'm going to keep going here. So yeah, now I'll sub. I can tell some people just like getting saucy now. Who made a saucy comment? I'm just talking to myself here. So let's see. So I sub my r in as h over 2, so right there. And basically it works out to be the exact same thing that we had in the last one. So it becomes 1 over 12 pi h cubed. All right, so if you need a refresher, you can skim back to the other one and look at how I got that from the last one. So you can see, if I go back for 1 second, that's the exact same thing I had there. So, and a lot of times that's what a cone will end up being. So remembering that's where you need to end up, it's helpful. Now, sometimes they might have a different parameter, but a lot of times that seems to be what, you know, most of the questions that I've seen and done in the past have been diameter and height are always equal. All right, so now it's derivative time. So I go ahead, take the derivative again of this. So you've done this already before. So it becomes 1 over 12 pi 3h squared times dh over dt. And then we can sort of simplify this a little bit. dv over dt equals 1 over 12. Oh, sorry, 1 over 4. Because you combine the 3 and the 12 to make 3 over 12, and that becomes 1 over 4. So 1 over 4 pi h squared times dh over dt. So now we can go ahead and sub. This one is not great for mental math because of the 2.3. And we also have the height is 3. But at the same time, it's not that complicated. So 2.3, 1 over 4 pi, and then it was 3 squared times dh over dt. And so you end up with 2.3 times 4, and I'm not messing with this mental math on a video because I will never hear the end of it if I mess it up. So that is 9.2. So again, this is just cross multiplication one way, and that's one of my favorite tricks to use when you're solving these types of questions. And then comes 4, and you can cook out 4 pi if you want it. So now I just divide both sides by that 4 pi. So and we end up with dh over dt equals 9.2 divided by 4 pi. And in all honesty, that would be perfectly fine if you wanted to leave that as your answer. I will divide it though, just to give you a different look. And again, this is totally optional. You can leave that answer. So that's 0.73, and this is the exact answer. This is the approximate answer. And that will be, I think everything is meters and seconds here. No, meters and minutes. So meters per minute for the change in height or the change in time. All right, guys, so that's a couple of cone questions. So I'll stop the video there. And thanks for watching. And we'll hopefully see each other soon.